Okay, so today we're going to talk about topic 4.3, so which is going to be on algebra and trigonometric functions, and then later we're going to talk about 4.4. For topic 4.3, so the learning outcome is that what we're going to do is we're going to simplify trigonometric expression by using some basic trigonometric identities that I'm going to introduce to you in a bit. And then for 4.4, we're going to solve the right angle trigonometry problem. So this will be the real problem applications. Alright, so let's have a look at 4.3, so algebra and trigonometric functions. As I mentioned just now, they're going to be identities that you're going to be applying in the problem, and these are going to be among those. So the first one that you should be very familiar with, so this is among the first identities that we have learned the first time that we have seen trigo. So which is when you have sine square theta plus cos square theta, that is going to equal 1. Okay, what happened is that when can we use this formula? So we can use this formula every single time as long as the theta are the same. So they have to be in the same unit, they have to have the same value and so on, then only you can apply this formula. For example, so if I come across sine square 90 degree plus cos square 90 degree, for this case, then yeah, what happened is that the angle are both in degree, and this is 90 degree, and this is also a unit of 90, so therefore this is going to be equivalent to 1. So as long as the angle is the same, so automatically sine square theta plus cos square theta is going to equal 1, but the condition is theta of course have to be the same value. And then we also have simplification for tangent. So according to definition, so tangent theta is basically sine theta over cos theta again. So these theta values are going to be the same. So for example, let's say if I were to have tangent of pi, so meaning that this is going to equal sine of pi over cos of pi. So all the angle has to be the same. And then this is going to be the property of the trigonometric function, the fact that secant is going to be 1 over cos, cosecant is going to be 1 over sine, and cotangent is going to equal 1 over tangent. I have my way of remembering this. So how do I remember this? So it's going to be opposite. So cotangent is going to be 1 over tangent, is kind of obvious. But then secant is going to equal 1 over cos. It's not 1 over sine, but it's 1 over cos. And when this is c, so the other one is going to be s. So it will be different alphabet at the bottom. So s become 1 over cos. C then become 1 over sine. So that's how I remember them. So they are always going to be the opposite. Secant is not 1 over sine, but it's going to be 1 over cos. Cosecant is not 1 over cos, but it's going to be 1 over sine. So this is very basic elementary functions of trigonometric that you should know. And there's another thing that I would like you to be clear about. So if I were to write something like this, so sine square theta, so this is actually equivalent to sine theta square. So they are actually the same thing. But this is not equal to sine of theta square. If I write sine of theta square, so this actually theta is being square, but that is not the case for this. So what happens is that not only theta is being square, but the whole sine theta is being square. So that is the difference between all of them. Okay, so be clear about this. So sine square theta, so when the square is in the middle, so it means that the whole thing is being squared, the sine and also the theta function. Okay, and as what we have done with polynomial function, so it will be the same idea for trigonometric function as well. So there are like operations that we can do for the case of trigonometric function. We can simplify them, we can expand them, we can factorize them. So those are going to be the same idea that we have seen for polynomial functions. So the only thing is that this is going to be in terms of trigo. So let's have a look at all of these examples. So let's start with A. Okay, for A, so the question asks us to simplify 10 sine theta cos theta. So plus 4 sine theta cos theta minus 16 sine theta cos theta. If you notice, there is a similarity between all of them. So when the question says simplify, so what we're going to do is instead of having 1, 2, 3, 3 different terms, I'm going to find somehow what is common between all of them and factorize the common term. And for this case, obviously, so sine theta cos theta is actually the common term between all the 3 terms. So therefore, what I'm going to do is I'm going to factor out sine theta cos theta. All right, so I will end up that the first term, so I'm going to have 10 and from the second term I'm going to have plus 4, and from the third term I'm going to have negative 16. And of course I can simplify this, so the fact that this is just numbers, so 14 minus 16 is going to equal a value of negative 2, so I'm going to end up with negative 2 sine theta cos of theta. So that is going to be the simplification. So now instead of having like 3 different terms, I can actually put them together, and it's going to become one term of negative 2 sine theta cos theta. So that is going to be for A. Okay, now let's have a look at B. For B, so the question said expand. So the idea of expanding is going to be the same idea of how you expand polynomials. So here I have secant square theta, so minus 3, so multiplied by secant square theta plus 3. Okay, so the idea is going to be pretty much similar. I'm going to have to multiply each of the term. So this is how it goes. So I'm going to start with the secant square theta, this one first. When I multiply by the other one, so secant square multiplied by secant square, so that is going to be secant to the 4 of theta. So why is that so? Because we have a secant theta to the power of 2, so multiplied by secant theta to the power of 2, or in other words, this is just a square multiplied by another a square, so which is going to be a to the power of 4. So that is why it becomes secant to the power of 4 theta. Okay, and then when I multiply 3 and the secant square, of course, it's going to become 3 secant square theta and minus 3 secant square theta, and the last term is going to be negative 9. And these two, they are going to cancel each other, and I'm going to end up with only 2 terms of secant to the 4 theta minus 9. So that is going to be for B, so when we expand the 2 brackets. So the idea is you're going to do exactly the same thing that you do when you come across polynomial problems. And then I'm going to have a look at C. Again, for the case of C, it says factorize. So the factorize idea is, again, so pretty much the same. So let's see what we have to factorize. So now I have tangent square beta. So I have tangent square beta, and then I'm going to have plus 8 tangent beta minus 9, plus 8 tangent beta minus 9. If you notice, so this is actually just a quadratic equation because I have a tangent and it's raised to the power of 2. The power of 2 is highest. So this is actually a quadratic function, but it is in terms of tangent. So can you use your calculator for this? The answer is yes. So how should you deal with this case? So the easiest way to do this is that, so I'm going to do is, I'm going to let x equal tangent beta. Okay, so if I let x equal tangent beta, so this is actually tangent beta to the power of 2. So therefore, this is going to translate to being x squared plus 8. So now we come across tangent beta. So that is going to be 8 of x minus 9. So you can use your calculator for this. And when you factorize this, you will end up with x plus 9 multiplied by x minus 1. So what happens is that your calculator will give you 2 values, x equal negative of 9 and x is equal 1. Remember, I did mention to you before that the sign is going to be opposite. So if you get a negative 9 from the calculator, so this is going to be plus 9. So positive 1 is going to be negative of 1. Okay, but however, so the end result has to suit with whatever that you have in the original equations. Now, so you're going to change back. So replace all the x to be in terms of tangent of beta. So therefore our factorization is going to look like this. So I'm going to have tangent of beta plus 9, so multiplied by tangent of beta minus 1. So that is going to be the outcome for C. So when you do the factorization, so if you come across something that is too complicated, so make it simpler. How do you make it simpler? You let that equal some variable that you are familiar with. So that is going to be one way for you to do factorization for this kind of case, so which involve trigonometric function. Sometimes the trigonometric term can intimidate us, so it looks very complicated when it is actually just a simple stuff that you have already seen before. And then for D, so we are going to simplify this. So let me copy this. And let's add another page instead. Okay, so this is going to be for question D. So what happened is that we are supposed to simplify this. I have sine theta minus cos theta over cos theta minus sine theta. So let me make it a bit smaller. I think this is kind of too big. Okay, what happened is that if you notice, so the term are pretty much the same. So at the top over here, so I have sine theta. At the bottom, I also have sine theta. At the top, I have cos theta. And at the bottom, I also have the term cos theta. So basically, they are actually the same term. The only difference between them is the fact that the positive and negative is different. So up here, this is positive. Down here, negative. This is negative, and this is a plus. So what I'm going to do is I'm going to try to factor out the sign. So I can write that this is going to equal. So I'm not going to change the top. I'm going to leave it as being sine theta minus cos of theta. But at the bottom, I'm going to factor out the negative. So I will end up with negative cos theta plus sine. Sorry, it's not going to be plus. So that is, sorry, it's going to be plus. So plus of sine theta. Or basically, I can put it the other way around. I can write that this is actually equivalent to sine theta minus cos theta over negative. So I can actually interchange the position. So sine theta minus cos of theta. If you notice, so this term at the top and this term at the bottom is actually just the same. So when I simplify, I'll end up with negative of 1. So basically, sine theta minus cos theta over cos theta minus sine theta when I simplify is just negative of 1. So that's it. So that is going to be for D. So now let's have a look at E. So what does the question wants for E? So E is going to be pretty much the same idea. For this one also, we are going to simplify. No, not here. So let's paste it there. And add another page. Okay, what happened for this case is that, so I have two fractions. I have cotangent square theta over cosecant square theta and plus tangent square theta over secant square theta. So my suggestion is that whenever you come across something which is in terms of tangent, cotangent, secant and cosecant, the first thing that you should do is change them to be in terms of sine and cos. So that is the way how you deal with them. So that is what I'm going to do. So each of this term, I'm going to change all of them to be in terms of sine and cos. So at the top, I have cotangent square theta. And we know that cotangent is actually 1 over tangent. And cotangent theta is 1 over tangent theta. And the fact that 1 over tangent, so tangent is sine over cos. So 1 over tangent is going to be the other way around. So it's going to be cos over sine. So that is what happened for the first term. So that is what I'm going to change. So let me put a box over here to tell that it's not related to D. So basically at the top, and because of the square right here, so everything is going to be in terms of square. So of course, if it's square, this is going to be squared, this is square, at the top is square, and at the bottom is also squared. So therefore, I'll end up with cos square theta over, so sine square theta, and that is going to be over cosecant square theta, and we know that cosecant is going to be 1 over sine. So when it's square, so it's going to be 1 over sine square of theta, and plus, and then I'm going to deal with tangent. So again, it's going to be tangent square, and tangent square is going to be sine square theta over cos square theta, and that is going to be over secant square, which is going to be 1 over cos square of theta. So now all you have to do is simplify this. So how am I supposed to simplify this? Okay, now we have an operation over here, so which is going to be division. So I'm going to change all the division to be in terms of multiplication. So I'm going to write this is going to equal cos square theta over sine square theta. So multiplied by, I'm going to flip around. So whatever that goes underneath over here, I'm going to flip it around because now we have changed from the division to multiplication. So it's going to become sine square theta over 1. So that is going to be for the first fraction. For the second fraction, I'm also going to do the same thing. So this is going to be sine square theta over cos square theta. And now division is going to become multiplication. So this is going to be flipped around. So I'm going to have cos square theta over 1. and I'm going to start simplifying them. So sine and sine, so it's going to cancel each other, so I only end up with cos square theta, and this is cos square theta at top and the bottom. They're going to cancel each other as well. So basically I'm just going to end up with cos square theta for the first term, and the second term is going to be sine square of theta. And we have seen this form before, so we know that using the identity, so cos square theta plus sine square theta, this is going to equal 1. So when I simplify, it is going to become 1. Remember, when you simplify things, instead of like having it in term of fraction, having in term of two fraction, either it become one fraction or it's going to become one constant and so on. So depending on how the complexity changes. And for this case, from having two different fractions, so we applied some mathematical operation, and it actually simplifies to become a value of 1. But my main point for this example is that whenever you come across something in terms of tangent, cotangent, sine, secant and cosecant, please, before you start doing anything, change them all to be in terms of sine and also cos. So that will be the the easiest way to handle when you come across this kind of functions.